Now in this video we'll look at example 18 of 4.06. So the question asks us to show that the line 4x plus y plus 4 equals 0 is a tangent to the parabola y equals x squared. So what does that mean? Well, they got a little diagram here. A line is a tangent to the parabola if they intersect at exactly one point. So the line could, well, say the line was down here, it wouldn't actually intersect anywhere. The line can intersect at exactly one point, like this one drawn here, the point being somewhere around there. Or the line could intersect at 2 points. So like this one over here, we've got our black parabola and our red line going through there, and it intersects at 2 points. So what we've been given is, we've been given two things. Okay, we've been given two things. Our line has equation 4x plus y plus 4 equals 0. And our parabola has equation y equals x squared. Now, what we're going to be doing is essentially solving simultaneous equations, but for a quadratic and a linear function together. Now, what this does is when we solve a quadratic and linear equations as simultaneous, it gives us a new quadratic function, which we can then find the results, find the intercepts from, or the intersections. In this case, we're only asked to show that the line is tangent to the parabola. We're not asked to find the actual point that it is. However, we could do that. But we'll just show that it is tangent to the parabola. So, here we have equation 1 and equation 2. So what we can actually do, sub 2 into 1, because equation 2 tells us that y is equal to x squared, equation 1 has a y in it, so let's sub 2 into 1. Therefore, we have 4x plus x squared plus 4 equals 0. Let's just rewrite that with our x squared at the front that we're familiar with seeing. X squared plus 4x plus 4 equals 0. Now, to show that it is tangent, therefore only intersecting at exactly one point, well, we can use our discriminant to show that there is only one root or one zero, and basically that's going to show us that, well, if there's only one root or intercept, well, then that's where the points intersect. If there were two roots, we might have something more like this over here, where you've got, here's your first intersection, here's the second intersection, sorry. Okay, so if we use our discriminant and show that there is only one root, well, for one root in the quadratic formula, we have this essentially, x equals negative b plus or minus the square root of 0 over 2a, because the square root of 0 is 0, you end up with that one x solution. So that means we want our discriminant to be equal to 0. So discriminant equal 0 for one root, or 1, 0. So from our equation here, we have a equals 1, b equals 4, c equals 4, so our discriminant equation equals b squared minus 4ac, which equals 4 squared minus 4 times 1 times 4. Now if you look at this, 4 squared is 16, minus 4 times 1 times 4 is also 16, which equals 0. So our discriminant has said, our discriminant is equal to 0, therefore the quadratic equation and the line only intersect at one point.